second order differential equation initial value problem by applying the Laplace transform to each term. When I apply the Laplace transform to the second derivative, here's my second derivative term. And again, here for the Laplace of y of t, we're just going to call that capital Y. We get s squared times y. There it is. S squared times y minus s times y of 0 minus y prime of 0. That's our second derivative. And then plus the first derivative, that's given here, the last entry in the first column. And again, this Laplace of y of t is just y. So we're going to get for the first derivative s times y minus y of 0. And then minus 2 times the Laplace of y, that's going to be minus 2y, is equal to 2t, is equal to 2 times the Laplace of t is 1 over s squared. So I get 2 over s squared. Okay, we want to fill in our initial value problem, our initial values. Y of 0 is 0, so this becomes 0. This one becomes 0, and y prime of 0 is 1. This one becomes a 1. And you want to combine all of your y terms. And so I'm going to combine my y terms to get s squared plus s minus 2 times y, and then I have a minus 1 is equal to 2 over s squared. I'm going to bring this 1 over to the right side, and I'm going to combine it with the fraction. So I have 2 over s squared plus 1. To combine these, I want common denominators, which will be s squared. So I'll write the 1 as s squared over s squared. So I get s squared plus 2 over s squared on the right side. And then to solve for y, you want to divide by s squared plus s minus 2. And that'll put an s squared plus s minus 2 in the denominator. Now s squared plus s minus 2 factors into s plus 2 times s minus 1. Okay, so we've taken the equation, converted it to really an algebraic equation that we could solve for y. And now to get our solution to the differential equation, we need to apply the inverse transform. And let me go back and look at number 11 and see if it's the same. S squared plus 2, and then you have s squared, s plus 2, s minus 1 in the denominator. So this essentially is question number 11. When you apply the inverse transform, you get y of t is equal to negative 1/2. It's over here. Negative 1/2 minus t. Let me write that first. Negative 1/2 minus t minus 1/2 e to the negative 2t plus e to the t. Minus 1/2 e to the negative 2t plus e to the t is our solution to the equation.